This is the Amp Hour Podcast, recorded October 7th, 2013. Episode 166. Whimsical, Wafer, Waffling.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Dude, what's going wrong with America? Not only is your government shut down, but no guns are allowed into the Dayton Hamvention.
We're starting with that one, huh? That's what we're going to jump right in.
I'm starting with that one.
Yeah,
I'm
okay.
jumping right in.
You love that.
I love it.
Know,
what?
Safety
what
first,
the?
Dave.
What the? Big red letters for people who haven't seen it on the Dayton, Ohio, where Chris is from. Well, you're not from Dayton.
No.
You're from Cleveland, Ohio, but same state.
Yeah, that's Dayton's not as cool as Cleveland, so.
Oh, right. Okay. So is Dayton somewhere between Detroit and Cleveland in terms of scale, is it?
Actually, no, it's smaller than both. Dayton.
You
Detroit's
know what I
pretty
meant by
big.
scale.
Oh,
At least we're not Detroit.
Oh, right, yeah.
Buy a house for the price of a VCR and all that sort of stuff.
Yeah,
Anyway,
all that, yes.
there's that Hamvention thing. It's pretty big. Is it the biggest one in the country?
Yeah, biggest one in the world, actually, as far as I know.
The world. There you go.
That's the one I went
Amateur
to
radio.
last year.
Yeah, of course. Right.
And they scheduled it on top of Maker Faire again this year, so
Oh,
it's I think both those they choose like the second or third weekend in May, and they do it routinely like that, so it's just always going to overlap.
Yep.
Which kind of sucks, but
boy,
is
is it a 1 day or a 2 day thing?
It's technically a 3 day. I think it's Friday, Saturday, Sunday, but Sunday's kind of dull.
Oh yeah, there it is. Right.
And
yeah, they reckon
Fridays
they had
when all the good deals happen.
24,000. Right.
Yeah.
All the boot sales, car boot sales. Sorry,
Yeah,
trunk.
exactly. Yep.
24,000 people attended, and no one is allowed to carry a firearm because there's big
I'm sure
red
some of them
letters.
were.
If you check out the right. Well, maybe they had an incident last year. I don't know if it was on last year's one, but big red letters.
I want to know
reminder.
what brought this up for you. Like, why did this come into your sphere of
I think somebody tweeted it or something. I don't know. Somebody
Okay.
pointed it out to me or something.
I mean, it's very realistic. This could have been on the website all years. Like, all the buildings in the States now have that. They, no.
Oh, really?
No firearms allowed. Yeah, because there's like permits for
buildings,
concealed
like
carries.
government
Like my work
buildings and stuff?
and every government building, yeah, usually. So
Right.
you have to have like a specific, permit or whatever. I don't know. I don't carry guns.
So you guys have concealed carry laws and then put up signs everywhere saying you aren't allowed to do that.
Right, yeah. It's basically like the
that makes
business can
sense.
say
Okay,
not allowed
right, I get it.
because it's like private property. So
Right.
yes, it's a weird
stories
culture.
are true that I've heard about, people having to check their guns in at the local Walmart. They actually take them off, the holsters, and they check them into the checkout chicks. They go in,
Sure,
get their
I don't
groceries,
know.
and come back out. And
I don't live in Texas anymore, Dave. I used to
Right,
live in
okay.
Texas. This is Ohio. It's a little bit more tame and a little bit weirder in other ways. So
you guys
it
are crazy, fair dinkum.
It is crazy. Yeah, it's not me. Whatever.
Right.
Guns have their place. Walmart's probably not one of them. Miss the last of the donuts or something, and you get angry.
Yeah, right. Oh, you guys are sad, really.
Whatever. It's like I said, it's not me. I mean, like I look at all this stuff. Like I look at like guns. They're a hobby, right? Like people have, they shoot for a hobby. That's fine, whatever. But sports are a hobby, and
Right.
Other things are hobbies. And I just look at them and I'm like, well, yeah, they're hobbies, right? I mean, like for me, it's electronics.
Exactly.
It's like everybody's got their
Yeah.
thing. So, whatever.
Right.
I could electrocute someone. I'm just saying, I could.
Right, you could walk around with a taser. No tasers allowed.
I'm sufficiently motivated, I suppose, but no, I'm not. I mean, like whatever.
Right.
But yes, not at Hamvention. Apparently, you're not allowed to. So that seems like about the right crowd. There's a lot of crossovers,
Right.
and
lot of big cowboy hats and.
No, I think more like like there's a lot of military radios there. Actually, I think there's ex-military guys, that kind of thing. So,
right, got it.
Yeah,
got it. Sad. That's all I'm saying.
What? Australia has kangaroos.
Oh yeah, they
I don't
just
know.
hop,
What am I
they
got
just
here?
hop down the main street.
Yeah, right.
Yeah. There's big signs up. No kangaroos allowed at the electronics conference.
Right. Yep.
You aren't allowed to bring your pet koala.
Yeah, exactly. Ah, yes.
Right.
Stereotypes abound.
Oh dear,
Flyby PC on Reddit actually made a funny pun about it, though. He said, "What about gun diodes? Can we bring those?"
Nice.
Yeah. So, what else is going on in the wonderful world of electronics and hardware, other than guns?
I don't know. There's a huge list of stuff on Reddit we should probably go through.
We have our usual list. I think the big one is...
Let's just mention... Hang on. Let's just mention our Amp Hour T-shirt.
Oh, yes, of course. The biggest news of all.
Right up the front.
Yeah.
Because, people may not listen all the way to the end because we're just talking about guns the whole show.
Right,
so
yeah, we'll probably
let's just get it over. Yep.
Yeah, we do seem to loop around. So white, it's coming in white this time. Some people were disappointed that it's not in black. Sorry, we did black already. But the difference here is that we also are offering women's size T-shirts as well. They're like a different shape, and so yeah, if you don't have a shirt, it's a good way to get one. I think they look pretty nice. I have a different different vendor's white one, and I like the white one. It's like kind of like an off-white shirt.
I'll have to order one, even though whites. I usually don't wear white T-shirts.
We should get
one
for the missus.
Pale as a ghost.
Right.
You think? I think I should get one for it.
I got one for the missus. Yeah.
Are they available in tiny sizes? Because there's another Yankee thing. You guys are so damn big that everything. Even your small size doesn't fit me. Because
yeah. Well, you can wear the lady shirt too if you'd like.
Right.
For your slim physique.
Right.
But if you look actually, so on like the Teespring site, they'll actually it changes the shape of what the shirt is shaped like too. So that those are size smaller and also more like form fitted for women. So yeah.
Cool. So you're saying I should buy one for the wife and
yeah, definitely
for
make
her
her wear
birthday
it.
coming up. Right.
Yeah, that's all you should get her.
Wear it.
You do great. Just make her wear it to the birthday party, and yeah. And that was the last we saw of Dave.
But all of a sudden, I've got a lot of free time.
I've never built more projects in my life.
Yeah, exactly. And speaking of white outfits, and
oh yeah. You've been dancing around like a crazy person.
Dancing around I've been doing hammer time in a bunny suit.
Yeah, I saw this today. I was like, oh, Dave's like wearing what I used to. So if you look at Dave's video, he
just
puts on
released this morning.
That's right. Yep. I'll link it in too. He's wearing a bunny suit or a clean room suit, and. He looks ridiculous because it is way too big, which is his joke about fat Americans.
Extra large, and that's American extra large.
American.
American.
Yeah. Yeah. Sometimes I would get stuck with those at the. So I used to wear these every day at work, which is terrible, by the way. But yeah.
Size? Does it come in lanky nerd?
It does, there's a variety of sizes. You kind of find your sweet spot, but sometimes, they were like shared, or basically what they do is like, once you wore them and threw them in the dirty bin, they would go take them out, clean them and get all the particulates off and then rewrap them up. And but if there were certain sizes missing, you'd be stuck. And so, you'd be flopping around in those huge shoe covers. And it's fun to try the first time, maybe even the second time. Everything about a fab is fun the first time.
You're right.
But you know what? Yeah. When you got to take your outfit off to go use the restroom, that sucks. It's not just fabs, but that's a rough lifestyle.
Yep.
So whatever.
How many years did you spend in a fab?
I spent 1.5 years in a fab.
Yeah.
Yeah.
This was in Korea, was it?
This is in Texas, but working for a Korean company.
Right.
Yeah.
Right.
Yeah.
So the fab was in Texas.
That's right. Yeah.
Right.
Yeah. Now they make a bunch of Samsung makes a bunch of chips for Apple and stuff down there too, which I missed out on, which is unfortunate. But I was making memory down there.
What's the difference? Chip's a freaking chip. Doesn't
No
matter
way.
what's printed on there, does it?
No, no way, man. Like, so the difference is like, God, okay, so like memory is like, what would be a good example here? I wish I would have thought of this beforehand. Making memory is like repetitive stuff, right? If you look at like a cell for like memories, I mean, like you're trying to do the same thing perfectly over and over and over again.
Oh, yeah,
And,
right.
everything's still measured by the gate width feature size. So, like,
of course.
51 nanometer, 16 nanometer, 22 nanometer, whatever node you're on for the process technology. But for memory, you're just trying to replicate stuff over and over and over again. Whereas logic, you have, you're going to have certain portions of your chip that might be logic-based, right? You might have, or it might be memory-based for like cache and stuff like that, or cache, as you said. But then, really, the masks are different for everything, right? So if you,
Of course.
well,
What's your point?
What I'm trying to say is, if you lose one cell in a memory, that's not as big a deal as if you lose one transistor in a.
Of course. So it comes down to a yield thing.
Right. Yeah.
Well, no, but I thought even the memories have to be perfect, or can they, it's not like they can route around them or mark them as, this one is 1 megabyte memory chip minus 1 bit. I
thought there might be logic in there. I mean, like, yield is still going to be measured in terms of 100%, right? You want everything working perfectly, but I think they might have been able to laser stuff out or something. It's been a while. It's been a while since I did that. Okay. So
anyway.
But yeah, Fab Life's terrible. I would not go back.
Right.
The tough thing too is like if you
fascinating. It's fascinating technology. Anyway, the tough thing is what? What is the tough thing?
That is, if you're working over by the photolithography, it's not as big a deal now, but it used to be all the photolithography areas, because everything's light sensitive, and because you would open up these boxes, there'd be all yellow light, and so that's just and so I worked in etch, and since we had stuff that had photoresist on it, and the older fab that I worked in, the yellow light, it was terrible.
Does that drive you crazy? Does that make you want to pull your gun out? Are guns allowed in fabs? In Texas, because do they let you carry around your
they do not
concealed
let you carry
inside
guns
your bunny suit?
in Texas.
No?
Nice, Dave. That's good. That's really, you're hilarious. It does. It gets to you after a while. I mean, I know people have been doing it for 10 years, and they're awesome what they do. It got to me. So,
right.
Yeah, it's for some, not for others. I didn't make it. I want to get back into electronics. So,
and it's awesome technology, though. So in the latest video, I've been playing with some stuff. I mean, our guest who's coming up in a couple of weeks, Vincent Himpy, sent me all this stuff. So thank you very much, Vincent. He probably listens.
Hopefully, because he's going to be on soon.
Well, he's going to be on it. So, anyway, like really cool stuff like the active FET probes that are used to probe individual points on the wafers.
Yeah.
Right. I mean, the tip is 100 nanometers.
Yep. Yeah.
And that's
crazy.
probably big, right? And that's probably a big one these days, right? That's
I don't know. I don't know how that changed. I mean, because depends where you're probing, right? If you're trying to probe on a pad that's like on a bond pad, that's huge.
Yeah,
right?
then
but
it's enormous.
I think
if you're trying to
what
probe
are those FET probes used for? Are those used for like what are those called? Tags or whatever. So in like silicon, I know that they have the main area where the actual chip is, but then if you look at like the areas in between where all the different active chip areas are, they always put test circuits out there, either for I know analog fabs will actually run like early run prototype tests in that area, but then I know in production style they actually put like like line width tests, kind of like your little ruler thing, how you have like you can tell. You can kind of tell how the process went based on that kind of stuff. I forget what they call that, though. I want to say tag, but it's not.
It is a test coupon. It's like a test coupon on a PCB. Is that what
there's
you're
another
talking
name
about?
for it, though, too. Yeah, I mean, it is. I mean, it is a test coupon. You're right about that.
There's a chip equivalent to that.
Yeah, exactly. Yep. So yeah, it's very fascinating. Actually, my second to last company, we built stuff for testing analog wafers too. That was fun.
Right.
And that, I mean, like, that's the thing. Like, I never realized any of that stuff. You know, like when I was leaving school, like who thinks about that? Like, oh, of course. Well, you're building wafers. You got to test them, right? You don't want to get all the way to the friggin' package where you're dicing everything up and putting it in packages and then test it. Then, you know, you could, but you'd end up wasting a bunch of money.
That's what I said in the video. Yeah, it adds up because you know what is a typical wafer yield on a 300 millimeter thing? It might, you know, what is it? 50%, 80% yield or something like that? No?
No.
Oh, I'm
yeah, if you do 50%, you're getting fired, buddy. No, I mean, like, I mean, that's like they all do, like, Six Sigma type stuff. They got to get to, like, 97, 98. Like, I mean,
then in that
bonuses
case,
are based on that kind of stuff.
If it's so high, why do they bother testing at the wafer level? Why don't they go through to full packaging and then, because if they're so wanky,
think about
Six
the feedback
Sigma,
time, man. I mean, like, so you got to send wafers out, right? You have to send wafers out to China because packaging is like China, Taiwan, a little bit, I think. But I think it's mostly China these days where they do like the wafer cutting and the die bonding and stuff like that. So you got to ship it over there. You got to cut it up. You got to put it into these packages. Then you got to test it. Like that feedback cycle time.
But you're Six Sigma confident that you're going to get a good result.
Perhaps you don't understand the Six Sigma philosophy. I don't really either. Let's be honest here. I hated that stuff. I hated that stuff. But it does its work.
It's important, and it does work. It does work, right?
But no, it's about feedback time. You think about
of course.
You know, getting through a fab.
I can understand that at the initial level of when you start a production of a new chip, but once you've got it sorted out, once you've built up that confidence in the history, why wouldn't you then stop testing?
How fast do you think you could get a wafer from Austin, Texas to China and then make it into cut it up, put it into parts?
But it doesn't matter. If you understand, it doesn't, because you don't need feedback, right? Because once your manufacturing process is good.
Just play along here for a second. How long do you think that takes?
Okay.
You think it's days to get from Texas to China, cut up, and put into packages?
Well, it could be as little as a few days, and probably a week.
So 5 days even, right? So from the beginning of the line to the end of the line is like, the stuff I was doing, it was like 300 different steps, right? Some of the logic stuff I think goes up to like 500 different steps.
Oh,
right?
I know where you're coming from.
Yeah,
if something
it's like
goes
a 30-day
wrong on your
cycle.
line, you've manufactured. Yeah.
Exactly. You think about 30-day cycle, right? And then you have 5 days to go take it to package. That's 18% longer than you would find out if you tested it right in the fab.
Got it.
So that alone is a reason. I don't know if that's the reason, but I think that helps. I mean, like, you think about how fast how long it takes, like, for you and I to design a PCB, get it made, even if I cut it on my CNC or we etched it in our house, right?
Yep.
Bringing that cycle time down is like so critical sometimes because you need to know if it works, right? If you can't put it on a breadboard and prototype something, if you have to use a QFN package and you need to get on your board, the faster you get on your board, the faster you know if it's broken or not, right? And then you can actually feed that back and fix it. And it's that same kind of the thing. It's about cycle reduction of cycle time, rather.
Yep.
And I'm sure I'm wrong in some way.
Just in case something goes wrong, because if nothing goes wrong, then you are, wasting all that testing effort.
Yeah.
But it's essential, because Murphy will get you as soon as you go, oh, we're pretty confident, we'll just stop testing now and just let them all go through. And that's when Murphy will, throw a spanner in the works.
And they start to scale it back, right? You go from like 100% testing at the beginning and then you scale it back, like any production type of environment.
Yeah, that's right.
But then you think about other things like you think about like an 8-pin SOIC chip, right? You might have 8 pins you can access. Whereas if it's an analog chip, you might want to know how much current's actually flowing. Say it's an op-amp, right? You want to know how much current's actually flowing out of your current source. And you want to know, how, if you've got, say it's like an instrumentation amp and you have like trimmed resistors in there, you want to actually know what the resistance value is exactly with a 4-wire measurement right on the chip versus all the inductance from the leads and the wire bonding and everything else. It gets intense, man. So it's totally worth it because they wouldn't be doing it otherwise.
Because those test heads, those automated test heads are absolutely amazing. Watch my video if you haven't seen it. And they have to hand make they have to hand make these for each different chip variant that they do.
Yeah. Yeah.
I mean, it's just incredible. And so you take it for granted that there's 200,000 chips available on DigiKey, all off the shelf.
Oh, yeah.
Right, but each one of those needs a bloody, this complex test head and procedures, and let alone the wafer manufacturing, just the testing systems alone.
Mm-hmm.
And if they're and if they're high spec analog chips, for example, they'll be thermally characterized.
Oh,
and
yeah,
they'll be performance characterized, and
there'll be binning too.
100%.
Binning's another thing, right?
Binning, of course.
I love the binning process because you can always tell
Binning's
when you
cool.
when you talk to like a vendor, right? And they're like, "Oh, well, we have different speed grades." And you're like, "Oh, really? How much more do you want?"
That means your processors all over the shop.
Exactly, right? Yeah, it's like, "Oh, well, we have." So we have like a 100 megahertz chip and a 60 megahertz chip and a 20 megahertz chip, and there's a $2 price difference between each one. It's like, oh, so they're all 100 megahertz chips. It's just some are better than others.
Yeah, that's right.
Yeah, and it's crazy too when you think about if you look at like where these different things come from, like on the wafer, right? So there will be different regions. So like this again with these test heads, they'll be able to tell you that, oh, well, because of the processing, you think about. So if people know how etching works like on a PCB, right? If you're doing like copper clad, and how if there's, if you leave it in the etchant too long, it actually eats away the lines and the lines get too thin, right? Well, the same kind of thing happens on a wafer, where on the outside, if it, say your gas head on an etch machine, right? Because that's what I knew. If your gas head on an etch machine is older, right, you might have a different profile where the outside of the chip gets thinner line widths, whereas the inside of the chip gets thicker line widths, or the reverse or whatever. And you don't even know that. You say, okay, well, it's within tolerance, but you don't know until the end when you're testing everything that the outside of the chip gets the 100 megahertz rating and the inside of the chip gets the 20 megahertz rating. That's some crazy data stuff.
I know, it's fascinating stuff. I love it.
Yeah. Yeah, so that's the kind of stuff I miss. It's just a matter that I was on the floor doing that kind of stuff.
Right.
It is interesting.
Knowing all this stuff, knowing all how complex it is to test and package these chips, you still think a chip printer machine is viable.
I didn't say it would be
unbelievable.
I didn't say it would be like a fast chip. I mean, I'm talking like a 555 timer or something. Let's start simple, Dave. Let's start with some old process technology. Saw that one coming from a mile away.
Sad.
Yeah. Well, it's crazy too. So actually another thing on our and we'll talk all about this with Vincent. I think Vincent said he would probably try and get a 4-hour show going, so people can watch out for that. But there was a news item this week that Tokyo Electron and Advanced Materials is AMAT, they are merging, and so you think about this equipment, right? So these are $30 million machines, right, for one thing, and you only have 5 customers around the world, and now there's even fewer companies that are doing it, and so I don't know what that's going to end up happening. I think about how that's actually going to affect us in the electronics side of things. I hope it won't have too much of an issue, but I think it'll actually raise prices on chips, if you ask me.
Right.
Because you think about, if they have more control of the market and they can say, well, that $30 million machine is now a $40 million machine, and then the fab goes, oh, well, that's not cool. And they're like, oh, well, we're all the same company now. So, okay, it's a $40 million machine. So hopefully that won't be the case, but, that might happen. So people should keep an eye out for that. If you see
does
prices...
it matter if a chip fab... Now, does it matter if a chip fab costs 10 billion or 15 billion? I mean, once you're up in the stratosphere like that, does it matter?
It just forces us towards that chip printer, Dave.
Right.
I mean, what it really does is so there's you think about starting a company, right? No one is going out, very few rather, because there might be one or two. No one is going out and building new fab equipment, without a history of doing it, because it's such a complex system. Yep. It'd be like someone being like, well, I want to build a Dreamliner, like the 787. I want to build planes like that big. How do you even jump into that market? It's just so complex that...
Well, it's like building a car. It's like the new Tesla Roadster. There's a reason why there's been no new car manufacturers for the last, 80 years or something. Tesla's the first, because it's just such complex business.
Yeah, it makes you wonder how they did it, huh?
Well, they hired a lot of
That's
people
true.
from Toyota and all those sort of places.
That's true. Yeah, I guess that does I mean, we saw that with Touchstone too, right? I mean, those guys are all ex-Maxim and Linear Tech guys, I think. So that is a good way to do it. But yeah, man, that's crazy. I was thinking about that today, right? So like startups and stuff like that. Have you seen any hardware startups with like young founders, or successful hardware type things with like really young founders?
There probably are, but no, most of them have some sort of industry experience. You know, it's not like they come, straight out of graduate school and bam into it.
Yeah. I don't know. It's I mean, like, I think, well, I guess the closest one I would think of is like Michael Osman, who was on the show, right? I mean, like, he wasn't young, but he's, he said he's been doing electronics for 4 years, so he had the software side of it, but, he got into hardware 4 years ago. And, I mean, 4 years is no short amount of time, but it's shorter than I would think, Well, like the Touchstone guys, right? They were 30 years of experience, right? Like that.
Yeah, that's right.
So I guess it depends on the industry. But man, I was thinking about that today because I saw this Tesla board. Have you seen this one? It's another one of these.
No.
The rash of
the
JavaScript based.
Yeah.
Yeah, I don't know where it came
grown.
from. But yeah, but. And they're pretty young, but I guess they're also working with Scott Miller at Dragon Innovation because they're doing. I guess we didn't talk about that on here, but Scott and his team now have like a Kickstarter type of startup crowdfunding platform as well. And so Tesla was going through this crowdfunding platform, and I saw these. I mean, they were like grad students, that kind of thing, and the project's funded and. Well, it remains to be seen if they'll be successful with the actual production of it and stuff. But I'm sure Dragon Innovation will help with that kind of thing. But I was just thinking, like, you don't necessarily see younger people as much, but maybe it's just I'm not paying attention to that kind of thing.
Possibly, yeah. I'm sure people will give us tons of examples.
Yeah.
Speaking of which, what happens when you get a couple of business people forming a startup and doing a crowdsourced funding campaign for a product? What do you end up with?
A really nice brochure.
That's pretty much it. I will link in a Possible, which is the Australian crowdfunding site.
Oh, this one.
I will the ICE ID tag. Right, this project is done by a couple of business, they're business people of some marketing, some description, right? They're not engineers, right?
Derogatory term.
Yeah. And it's a wristband, right, with a unique number on the back. So they just print a unique number on the back. And then, of course, they have an app for your phone that allows you to reference a database. Sorry?
Wait, is this which one is this? The ICE battery?
No. Sorry, no. I'm confused. I've got two things with ICE in the title. No, this is the ICE Emergency ID. I'll send you the link. Here we go.
This is like our regular calling out. It always seems to happen on Possible and what's the other one?
Indiegogo.
Yeah, that's the one. We're like the open funding
Indiegogo,
campaigns.
where all the dodgy ones are,
Yeah.
Exactly. And I might talk about the ICE one, the real ICE.
I don't know if we can take that much.
Well,
I don't know if we can take that much.
Anyway, this one, right, here's an example. I'll link it in. Check it out. An example of what happens when you get two business people doing a startup project. Anyway, it's a wristband, unique ID on the back. And and they've written an app for it as well, tied into a website which just has a database of all your information. So, like your emergency contact number and, what you're allergic to and, I'm allergic to peanuts and blah, 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 right? And it's for active people, right? So when you're riding your you're biking your triathlon or whatever and you get, slammed by a car and they find your crumpled corpse on the ground.
Separate from your body.
Yes. Yeah, I found an arm. Yeah, well, it's got it's got a wristband. It's got a number on the back. I'll whip out my smartphone and download the app, and I'll type in the number, and fail.
You know, it'd be funny if you had
Fail.
like a chip person like staring at like the bush where the arm fell into it, and they're like, man, everything's got an arm in it these days. But
Ka-ching, I'll pay that one. All right. Yeah, well done. Anyway, it's just something that can be accomplished with a piece of paper. Right. But no, they had to go through the process of, it's got to be an app because that's what we learned in business school, makes money and great startups and all that sort of stuff. And the money goes towards, they're looking for like $7,000 or something, or they need 15 all up or something, and $5,000 goes towards a new website, $5,000 goes towards legal services and website terms and conditions and health compliance, and $5,000 goes towards marketing. It's like, where's the manufacturing in? Oh, they've got a couple of grand for, we'll buy some stock of the wristbands, but all the money's going into legal, marketing, and just fail.
Yeah. Yeah, that is amazing to me that
face
people
palm worthy.
That they just want to, have people pay their costs for them, really. I mean, like, I was thinking about this with actually I was talking about Stompy with a friend the other day. Remember that hexapod robot Kickstarter I backed?
Oh, yeah, right. Yeah.
And I was saying that was surprising to me because it was, it was big, right? It was $65,000, but it got backed. But it was big because it wasn't like you'd get anything for it, right? I mean, like, I got like a bumper sticker, they had T-shirts and, wristbands. And, like, I love the concept of it, but, it wasn't like you got anything, whereas, like...
No, that's right.
A lot of the successful Kickstarters these days do have, you're getting something for your money, right? And
yes, you're getting something tangible.
What's driving a lot of the growth of it, to be honest.
Absolutely.
It's surprising me when... especially business students, you'd think you'd be like, okay, well, come on, guys, this isn't just like free lunch, but...
Well, you do get a wristband or something,
This is not going to be the last one of these. I mean, let's... Yeah, Dave, this is not the worst one you could have found.
Oh, no, it's not. It just happened to be local Australian one, and it happened to be just, two business people, and they itemised where they were spending their money, and it was all in, marketing and legal, and, it's just, no.
Right. Yeah, that's
and
very odd.
And it's and it's that classic example of they got together in a meeting and they brainstormed the idea and they just brainstormed it so hard that all their brains just oozed out of their ears and they came up with just this shit idea which could have been this overdone idea which is easily accomplished with a little plastic card or a slip of paper. But they had to go all high tech. It's just no.
Let's talk about ideas we do like. I agree. This is stupid.
Yep.
So here's an idea I do like. This is from a hackerspace up in Seattle. You were looking at this one as well, right? The church,
yep.
Circuit Church.
I don't like the name. That's just shit.
Yeah,
no,
I think it's funny. So it's because it's on Sunday, so they call it Circuit Church.
Once again, bloody Americans, guns and churches. That's all you guys give a shit about.
Yeah, I'm sure
really?
Seattle's really known for its churches, Dave.
Right. It is still America.
America.
You
you got to work on that. America.
Yep. I'm sure I've just had a whole bunch of people unsubscribe because I made fun of their country again.
Whatever. But yeah, this is a great idea. So it's a Sunday night at 6 p.m. You show up. You use Upverter, right? We had the Upverter guys on here. You if you haven't designed a lot of electronics before, you just kind of move into the layout side of things and kind of work alongside and kind of get to the manufacturing side of things. And then they actually have an LPKF, which is the laser-based circuit board cutter, which is awesome. And they actually cut it on site, and then you actually manufacture it. And so, like, these are smaller designs, but, like, that's awesome. I mean, like, single night design iteration.
Yeah, you go from go to woe, yeah.
Yeah.
In a single night.
For $30, that's like this is a sweet deal. So anyone who's in
dude, that's putting
Seattle.
your contextual electronics out of business. You're just
that's tough.
People
right?
have to watch 150 videos now. They just jump straight in, and in a couple of hours they can produce a book from go to woe. I think your whole concept's just falling apart.
Well, there's two things, right? I mean, like this is Seattle, right? If this kind of thing happened everywhere, then I'd agree. Like I'd go and do this kind of thing.
Yep.
And, I was talking to the guys online about this, why they used Upverter over like KiCad, like I use. And they said, Upverter's good at like smaller but like fast design iteration, and you can do the collaborative stuff. So if you need to help someone out, you can jump onto theirs and actually move traces around. And I think this really is going to be a good proving ground for that kind of like social design process. So, more power to them. I think that's going to be really cool. You're never going
to be able to do anything serious with it.
I don't know. I can't say I've used Upverter enough to... You mean the CAD stuff or the actual manufacturing of stuff?
Yeah, I'm talking about the CAD software and the whole process. It's like when you get into real serious, design, you've got to change your process, really.
That's tough just based on the beginner level, right? So this is like beginner level. I'm doing more kind of like intermediate level, 4-layer board, that kind of thing.
Yeah, of course, yeah.
But yeah, I mean, like this is a beginner level, but this is a good start, right? I mean, like
of course, totally.
And I think Upverter is definitely possible to do that kind of stuff, but it has to be more, even in the social context, it's going to be more of the, like you would use it, right, and then other people would be able to watch it, simultaneously. That kind of thing would be like, like they even said, the Upverter guys said, it's like having the I think Michael said this too about the KiCad thing, having the designer or having different portions of the design where one person is in charge of it, and I've seen that in other contexts as well of needing to have a final say, really. That's what's important for this kind of stuff. So
it has to be a dictatorship. I'm telling you, dictatorships work. It's the only way to do design.
Now the Americans are mad at you. I agree. I totally agree with that.
I think
you can apportion. I think you could portion out designs, but you can't. Yeah, you still. And I was thinking about this concept the other day too. I forget who talked about it. There was a book that talked about it. But at Toyota, they have something called a chief engineer. Have you ever heard about that?
I've heard of the title. Yeah.
Yeah.
But it's like how it fits
maybe it was someone on the show. I hate when I quote things that I don't know where it's from because it could have been you saying it, could have been me saying it, could have been someone else on the show saying it. Anyways, but it's about chief engineer is like he's like the final say in all things, like all designs. And I think the example they were talking about was like reworking one of the minivans. That was the example they were talking about, like the Town and Country or something like that. Well, I don't know what the Toyota ones are, But yeah, it's a great idea. Even any kind of design like that where you have a team, you have different modules feeding into it. You still need someone to say, you need a system designer, right? That's the concept of system design. So, this is a good segue actually. So I get to meet with system designers sometime actually for Silicon. You ever used to do that?
Oh yes. Yeah. I used to do that.
Yeah, so they're called product definers or system designers or system architects.
We used to have the actual we used to have the guys who actually design and lay out the chip, come and talk to us and
Right. Yeah, exactly. And that's awesome. Like so that's what happens a lot when usually when you're a bigger company, they want to be able to like try and tailor definitely to your like whatever market you're in. They're trying to basically do marketing up front where they say, okay, Dave, you were in the what was it, the vibration
seismic
monitoring
industry.
Seismic, thank you.
Yep.
Yeah, so like they want to talk and find out what do seismic electronics designers care about.
Yeah, exactly.
And then they design that into a chip, and then you can simplify your designs, and that's where all these modules come from. So I was meeting with one the other day, and we were talking back and forth, and I'm not going to talk about what the actual chip we were talking about was. However, we were talking about the basically things I'd like to see in it, and I came up with this idea that I think is actually really good, and I'd like to see in more chips.
Of course you did. You think it was a killer idea.
Well, yeah, and
patent it quick.
I'm not saying that it's like patentable or anything else, right? But it's an idea that was like on the spot. But like I started thinking about it afterwards, and I'm like, well,
I'm not saying it's good.
I
came up with a ripper.
I was like, oh yeah, pat myself on the back there. But no, what I was thinking about was, I don't want to, so I told this in a meeting, right? And they're all scribbling furiously, right? And say it was a good enough idea, well, what if then that company goes and patents it? It's like, I think it really comes down to an ethical kind of thing of like, even if I don't talk about the chip itself.
Companies aren't ethical, end of story.
Well, yeah, but I mean, people are ethical, right? And I'm trying to be ethical as an engineer, right?
Right.
And what I'm saying is that if I want to see this in more than one product, right? What are the ethics of if I'm in a meeting with someone and they prompt me with whatever they're working on, and I come up with an idea that's generic enough that it could be in a bunch of different chips, but then they go and integrate it and patent it in their chip. What are the ethics of going and saying that to someone else, right? And because it's not illegal, right? I mean, like there was no. I'm not going to talk about what they talked to me about, but this is something that just came out of my brain. It's not like they have final say over that. It's like I'm not going to talk about what they tell me.
I mean, the answer is, it's ethically fine, but your problem is, I think what you're getting at is that they're the ones who prompted you to think of it. So you kind of think that maybe ethically they have some sort of ownership over that, perhaps.
Right. If Doc Brown showed up at the meeting, right, and he said, "Right, don't talk to them about that." I don't know, I can't do a Doc Brown voice, but if I went back in time and that that prompting didn't happen, would that idea have ever come up, right?
Right.
So it's
I guess you still came up with the idea. And then, no.
Okay.
Hell,
okay,
give
so
it to everyone.
So that's what I was thinking, right? Okay, so I agree with that mostly, and I think that it's not specific to their chip; it's a generic idea. So then the question is, do I offer that to other vendors? Do I talk about it on the AMP Hour? Do I
yes,
publish it?
And
well,
yes to
so I got into this talking about it on the subreddit about the yes, but the thing that was interesting then is like, okay, so how far do I want to take this, right? So say I like this idea enough, which again, I'm not saying it's a good enough idea. Do I put it in the public domain? Do I take it,
Yes. As I said, yes, and yes.
This is worthless.
To the future things you're going to say. Yes, do it all. Bloody oath. Because what it comes down to is something that ultimately you and me and every other engineer will hate in the end, that if they patent the damn thing and then they're a single source for that chip with that idea, then you're ultimately going to be screwed. So screw them first before they screw you.
Oh, Dave's figured out business. Yeah, right. Dave's MBA classes will be back in a minute.
Screwing 101.
Yeah. Different class, Dave. That's a different class. Well,
how to screw without getting caught.
Yeah.
102.
Yeah.
How to screw while making friends. 103. I could go on all night.
I know you could. Yeah. So yeah, basically the idea is though, like, so basically if I really wanted to take it to the point where I didn't want anyone to patent it, basically it would need to be in literature somewhere as well. So that's the other thing. So it'd have to be a written idea, because what I was talking to with Ken about on Reddit was, like, no one cares about podcasts. Present company excluded.
They do. No, technically that is prior art. So if it went actually to a proper patent
you think the AMP Hour is
lawsuit,
going to be the first patent case?
This is the industry's leading podcast. Absolutely. You could use
Finally,
this
it has some use.
No, absolutely. Abso-freaking-lutely. It went out there. It was widely published, widely publicized in the leading industry podcast. Absolutely. I'm sure that if this went, any patent lawyers in the house, any patent, as in
your brother-in-law is one, isn't you?
Yeah, but he's a patent. He just writes patents. He doesn't prosecute them. So you'd have to get a prosecution specialist. Like that guy who did the blue jeans cable. Against the monster cables thing. You'd have to.
Yeah.
Maybe we should try and get him on the show sometime. We could have a whole show on patents, and geez, that'd really turn our audience off, wouldn't it?
Maybe that would be a special extras kind of thing.
Like you have to show there was prior art, and it was obvious to a practitioner in the field. That is another thing.
Right.
If it was
Right.
obvious to you, then it would have been obvious to others. Therefore, it's not patentable.
Yeah.
You know?
Well, and that's what I really think about this in the first place is that, this idea
Right.
I came up with, I guarantee other people have come up with it before, or it's just a terrible idea in the first place. So
Right.
that's,
Doesn't stop anyone patenting the damn thing, though.
Yeah.
Just like this Ice Cube project.
No,
Generate
I don't want to
power
talk
from
about
ice
that.
cubes. No,
I don't want
let's
to
not
talk.
go there.
I don't want to talk about that.
No.
Carnot
No.
efficiencies. That's all I have to say about that. That's what I always have to say about energy products.
Oh, you put one on the list. Some energy orb or something.
No, that wasn't me. I don't think. I think that was someone else.
Ah, right. Somebody. Yeah, right. Let's not go there. Yeah.
Right.
Free.
Well,
Yep.
how about? Did you see those pictures? We were talking about die bonding before. I wanted to call out John Janier's pictures that he posted on Twitter today. Did you see those?
Yeah. I saw those. Yeah. Very nice.
They were gorgeous. Yeah. So we were talking about die bonding and like testing on die and stuff like that.
Yep.
But then the actual process of bonding from a silicon wafer over to a package pin or something like that. It's it's an awesome process. I think we talked to Tony Long about that when he was on the show.
Mm-hmm.
But yeah, really cool process stuff. But yeah, John took these awesome pictures up close. You could see all the bond wires and everything like that for like LEDs and I think what else was on
cool.
there. Some of the modules.
Yeah, I love looking at that because you just know as an engineer, you just know the precision engineering that goes into it. And you just go, yeah, that's cool shit.
Yeah. Did I ever tell you the guy I met who was doing his PhD thesis on solder?
No.
Yeah. Yeah,
what a fun stuff.
Oh God, I just like stared at him like, really? Like, I mean, he was like a materials guy, so like he actually.
Oh yeah, no, there's 1,000 different avenues you could do a PhD on soldering. I'm sure.
Yeah, it was intense, but it sounds boring as hell.
Well, someone's got to do it, right? Someone's got to do the basic research on this.
Well, I mean,
shit.
like you think about these pictures John took of like these the CC3000 module, right, from TI, which is that Wi-Fi module. Those are actually chips, like, soldered onto really tiny FR4. Like, they're like that. You get really like chip scale packaging type stuff. That stuff gets insane. They have recommendations and stuff, and I'm not very good at the solder side.
Recommendations can be a world apart from what happens in your assembly house on that line with that operator on that day. You know, I mean,
yeah,
right.
And so
tricky business.
the physics of how that solder flows at those small geometries. It's, I mean. I can't do anything without tons of flux these days anyways.
Right. Flux is the answer to everything.
Yeah, it is. I love sitting under a microscope, or sitting over a microscope, I guess. Yeah. And like watching, like, especially like on big heat sinked components, right, where you have to have like a hot air pencil on it for a while.
Mass. Yeah.
And then like as it slowly starts to melt and everything, like just seeing the it's like that scene in The Matrix where Neo touches the mirror and then, that like shiny, shimmery type of look. That gets me every time, man. I love that. It goes
through a little known name for that. In certain types of solder, only the plastic region.
Oh, really?
Did you know that? Yeah.
I did not know
that. There you go. I do know my solder.
Oh, yes.
There are certain, some solders have a plastic region. Go and Google that.
So does that mean like they're... What is the plasticity usually? Doesn't
Google
that refer
word
to like
for the day? Google word for the day. Plastic region.
Yeah.
I'm sure I've got that right. I better Google it myself.
I'm thinking of plastic deformation. I'm thinking back to statics class. That's definitely different.
Right.
Yeah, that's where it's like only deforms one way and it doesn't go back.
Okay.
Yeah. Huh. That's cool though. But yeah, I love that. If people ever get a chance to solder like with a microscope, I think that's the best thing to do. Just watch the solder flow and get like then when you get like the reflections off the shimmering top of the solder too, and you like catch like the eyepiece of the microscope too. Yeah, it's like, man, that's crazy.
It's pretty sweet.
Yeah.
Speaking of which, I'm contemplating. I don't know if I'll do it yet. I'm contemplating doing a live soldering demo at the Sydney Maker Fair.
Oh, that'd be cool.
Like, as in, like, under a microscope, it'll have
it up on a big screen
projector thing, and there'll be an audience, in one of the presentation rooms, and, do sort of like a live demo. Yeah.
What would you cover there? Like drag solder type techniques and stuff?
Oh, it'd just be pretty basic stuff. It wouldn't go into anything, it might finish off with drag solder in SMD, for example. That might be as advanced as it would get.
Okay, well, that's a good idea, though, because
preheaters and BGAs and everything. No. This is for, because it's for absolute beginners, right? Who, how to solder. I've heard of this soldering, I don't know what it is. It'd be, this is a soldering iron, this is the hot end, and
do not grab.
Yeah, right.
Well, usually most maker fairs have tents where they teach people how to solder. Like they'll teach through hole soldering and stuff like that.
Yeah.
And that would be,
but this
would
be if they have that, then I think it could be a good tie-in, because this would be like a formal presentation. Here's how to solder properly, the theory. Now go out there to the tent and, give it a go yourself.
Try it yourself, yeah.
Yeah, exactly.
Go burn some fingertips. So. It's the only way you're going to learn.
Suck up those rosin fumes.
That's right. Delicious.
Oh, boy. Hey! Hey!
A is for horses. A is for oses.
Popular Science. I've turned off comments on their websites.
Yeah.
That was a while back. But
that was a while ago.
I don't know. Thoughts?
I think the rage has subsided.
The rage has subsided?
Yeah. I was a little... at first, I was like, it was just how they wrote it. That's what it really got to me on that whole thing. So what they did is they said, oh, well, we're turning off comments because there's
too many
reading
trolls
the comments affects the actual perception of the article, right? And it's like...
Right, it affects the science. It affects the...
Right. And it's like... Because you don't want... Why don't, you could just hide the comments. I mean, this stuff has all been hashed over 100 times. But honestly,
you moderate them. If there's any shit ones, you delete them. If there's any links to crack, anti-science websites, you delete them. Boom.
Yeah.
You just, yeah.
Heavy-handed moderation is always the answer, right, Dave? That's never caused any problems.
No, I can understand why you would do it on a proper science blog.
Yeah.
You don't want trolls in there linking to, bloody alternative energy, free energy devices and all that sort of shit, Yeah.
But yeah, I mean, I think someone linked me a post about comments. I forget who it was who linked it to me, but it was actually so as much as Popular Science was kind of sensationalistic and we're not doing this anymore, and don't bother yelling at us about it. It was this other one was really a well thought out discussion about, well, what is the real benefit here? And that's that's the one that I would also point people towards, is the discussion of comments, especially these days. I mean, it makes more sense. I mean, the way the other guy said it, I'm much more behind it than when Popular Science wrote about it. So,
got it.
Whatever. Who reads Popular Science? That's the other thing. I don't. I used to. Do you read Popular Science?
I've not on a regular basis. I'm always searching for science articles. If they pop up on the news websites or something, I'll go over there, but I don't subscribe.
Right, and I know that's not the point here, but it's I don't really deal with them, so once that was passed, I was like, whatever. Yeah. Whatever. You know how YouTube is, right? YouTube's nasty, right? And I'm sure if you turned off comments tomorrow, you wouldn't be weeping too much, right? I mean,
well,
other than you get more emails.
As I said in my Ignite talk, there is no more wretched hive of scum and villainy than the YouTube comment section.
That's right. Yeah.
I've just banned a few people and idiots and stuff like that. So
yeah, what are you gonna do?
Yeah, exactly.
You spend a lot of time on your forum though too. That's the other side of it, right? It's
yep.
You gotta balance that.
Yeah, I've got to balance that. Because I'm a huge free speech advocate. And here I am having to, not moderate stuff on a post by post basis, but really sort of keep things on topic.
Yeah, right.
Yeah, how I have to keep the peace and. I can't have people going around, saying you're an effing so-and-so on my forum. That's just not the... Yeah, because then it just... it degenerates into, chaos, and then it drives everyone away. And, you need a...
Right, and then no one sends you crap anymore like that awesome stuff that Vincent sent, because he is on your forum, right? That's how you got to know him, right?
Yeah.
So that's awesome.
So it's one of those balancing acts. How do you balance your right to free speech but keeping the peace and keeping a nice and nice active community, working properly.
Yeah.
It's tough. It's almost impossible.
Yeah, it's tough to do. But, good communities usually prevail in that kind of way. I mean, like they're self-sustaining, I think, and as
they're
long as
self-moderating. That's how I like to run it. I like to think, people lead by example, and those who are real assholes just simply get booted.
Yeah,
that's
exactly.
And yeah.
Well, speaking of big communities,
no free speech for you. Like the no soup for you.
Right.
No free speech for you.
Right.
Go somewhere else and exercise your free speech.
It's a dictatorship, right, Dave?
Right, yeah, it's a dictatorship. It's
Benevolent overlord, works. Dave Jones. Speaking of communities, though, the Arduino community just got a little bigger. Did you see all those big announcements from Rome?
There's a big announcement every bloody week. Every man and his dog's doing a new bloody Arduino. Now it's Intel, and now it's blah, 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 running blah,
okay,
blah,
so
blah.
let's talk about this, though. It's interesting for different reasons, and it's not like, Intel just said, well, we made a board with like the same headers as Arduino. This is like, we co-developed the board with the Arduino team, and so did TI, right? I mean, so this is this is them trying...
Oh, it's great for them, It's fantastic. But I'm just saying, from someone who watches this sort of stuff point of view, it's just getting boring. There's just so many variants of so many boards, and there's just a million. If I want to use one of these boards, in a real project or something, which one do I choose? There's millions of them.
That is a good question, and I'm sure our friends at Make and everywhere else would like to give you a top 10 list, and you could read that and figure out which one's good for you. Personally, I think like with the Arduino, this is basically like tacking a Arduino onto a BeagleBone, right? So that's interesting from that perspective. Mm-hmm. But really, just in general, I think it's just a bigger question of like the Arduino platform is very big, right? I mean, and for good reason, right? It's accessible. It's it's a good team behind it. All the great community, right? All those things are very good. But then it's like, at what point is it no longer an Arduino, right? It's like, is it just the name on it, or is it like just the headers, or is it, does it just have to be compatible? Because, I mean, they're adding a ton of stuff.
It depends on what you're doing,
yeah.
Right? It doesn't have to be the headers. That's just a prototyping thing. It's the environment. It's the programming environment you use. That's it. End of story.
That's true, yeah. It does have to compile it down to that same kind of simpler...
And it's got to use the libraries. It's got to execute without fail under the Arduino IDE. That's it. And that's all it comes down to is the IDE. Everything else is optional.
Yeah, I guess
if it doesn't use the Arduino IDE, then it's just an Atmel or a microchip or a whatever or an ARM project, right? Even if it uses the Arduino headers, it's no longer if you can't program it with the environment. And of course, if you're doing anything custom, you generally won't be using the Arduino headers because it's just for prototyping and stacking and you just customize your board and you don't bother with the headers.
Yeah, you might drop down on AVR before, or now you can put a Sitar or whatever's on there now and Intel.
It's all about the IDE.
Yeah, that's a good point though.
Yep.
Which is interesting that has maintained itself, because like in the you think about in the programming world, it's like I always see people talking about like new programming languages and new this and new that, and there's really no unifying feature there other than it's code, right? I mean, like because I feel like people always just want to keep writing new types of code or new types of languages and new types of operating systems, that kind of thing. It's not necessarily that there's any like unifying element there. Maybe I'm wrong. I don't know, but
there's nothing new with the Arduino, of course. We all know that. It's, it's just a nicer IDE environment. It's still C. It's still basic C. It just has, a lot of precompiled libraries and sort of, and it auto downloads to the board a bit nicer. But, apart from that, it's no different. As I said, it's nothing new. People have been doing this for, I don't know, 25, 30 years since microcontrollers.
Yeah, right, exactly. PC 104, all that stuff, yeah.
Yeah, and all of this choice business I'm complaining about, Well, I shouldn't be complaining about choice. Choice is good, right?
No,
but,
yeah.
it's just a pain in the ass when you've got to go choose something, because then you get the anxiety, the engineering anxiety. That can be the name for today's episode.
What is it? Analysis by paralysis?
Analysis paralysis.
Or the other way around.
Anyway,
Words.
nothing new there. As you said,
once.
like PC 104, before the internet, before the communications revolution, you'd flick through, you'd have all these manufacturers, all their catalogs of all their PC 104 boards. Holy shit, which one do I choose? There's 20 manufacturers and there's, and each one has 20 different models of board.
Yeah. Well, I think what ends up happening usually is you have like certain communities coalescing around certain platforms, right? So you'll have, you might have a robotics one around the TI one, or the like the higher level computing type stuff around the Intel one. I think the interesting thing with some of these,
same in companies.
Yeah,
we've talked about that before, right? A company, you'll use that chip because that's what your company uses, even if it's not ideal for the task. That's what you use.
Yeah. The activation energy is very high, right? To get something moving again.
Right, to get something new.
Different.
Yeah. Yep.
Yeah. Well, I think the other thing that's interesting with these boards, I mean, like, these are like, they're getting complex, right? And so it's like the Arduino IDE is still there, and you could still, download and compile code for all that stuff.
And flash a LED and...
Yeah, right, yeah. And that's all similar still, but then I think about the scaling out, right, and actually taking advantage of these Intel chips. The Intel chip is beefy, right? So is the TI chip. These are beefy parts, right? And you want to like run Linux on it and actually do all that stuff. It's like, well, then you are necessarily moving outside of the IDE because you're compiling for that and downloading to that kind of thing. So it's an interesting thing into the mix. I think.
Well, I haven't looked into the detail there. Are you saying that this new Intel board really, because it's running Linux, or any of these boards which are running Linux, you essentially abandon the Arduino IDE and it only becomes a header?
No, I think it's like a coprocessor type of thing. Like the wireless board that the Arduino team released, the Yun, or however you say that, the YUN, one of the newer boards, that has the TI CC3000 module on it, I think, and it's running a Linux real-time operating system, because you need that stuff, right? You need real-time operating systems to handle stacks and all that other crap that you need. Even for USB, you often need that stuff if you're not doing it as serial, right? Yep. And so you're going to be outside of the. You're not going to write that stuff. I don't think in the Arduino IDE. Maybe you are, but I think
you can. You can do Ethernet. You can do TCP/IP internet stuff on there, but it's. Yeah,
the way I understood
not as nice as doing
was like you're basically like writing and reading to a set of registers, and this kind of the coprocessor's doing its own thing, talk to the internet, that kind of thing, and then you wouldn't really update that as much, right? At least for the Yun, I think that's what I was thinking it was, is because you're talking to Wi-Fi, but then basically you have a standard interface you're talking to with the Arduino basically, and then it's just a function call. That's a wild guess, but I think it's a pretty good guess, because that's how I would do it.
I think you're pretty,
yeah. So I mean, but it's interesting just from the, more people jumping in. That's a good sign. That means that all these big corporate partners see it as a lasting thing, lasting legacy. And Intel giving away 50,000 of them. That's kind of odd. It's like, hey, we're still huge.
Yeah, exactly. We're still relevant,
Yeah.
Please remember us.
Yeah. Yeah, I don't know. Like, well, it's like the Minnow board. They just had the Minnow board come out too, which is really cool. I mean, like, the fact that everybody's doing open source, that's great. I mean, the fact that they're trying to build up communities, that's great. All these things are really good. And at the same time, part of my brain is saying, well, are they really going to make it though? Like, I mean, like, so unless you need these, like, these Intel boards are like $60, the Galileo, the one with the Arduino platform. It's like, okay, well, is it worth that extra $35 to get all that other stuff? And it might be, but it might not. I mean, like, I don't know. So I guess the market will tell with that kind of thing.
Absolutely.
But if you're given one, I mean, I'm sure you'd go for it.
No, you'd use it, exactly. You're going to use what you have to hand.
Yeah.
If I need to do something and I've got an Arduino sitting next to me, I'm going to use that. If I've got a Raspberry Pi sitting there, I'll use that. If I've just got something else, I'll use that.
Yeah, I agree.
That's what it comes down to. Yeah.
I think it was on Jack Ansell's newsletter actually. maybe I mentioned it on here, but there was a guy that was talking about it where before he would dig in his drawers for like a 74 series logic, just to blink an LED kind of thing. He just needed that. Right. And it was just easier for him because he had an MSP 430 sitting around.
Right.
Or the, whatever it's called, the Discovery board or whatever that is.
Yeah, yeah.
Or the Launchpad. He had one of those sitting around. He just wrote a loop because he just that's all he had. And it's right. I mean, like, you can do that. It's just, I think it's only a problem when you don't, like, that guy obviously had the experience to be able to go and use the 74 series logic when he needed to. I think a lot of the, kids coming out of school where they're just handed these boards and it's like, that's the answer. It's like, now you have these heavy-handed techniques for doing something very simple. Yep. And it's not always the best option because, power and all the regular design constraints that come in, you might want to just do it with a 555 timer or something.
But once again, there's nothing new there. Engineers have always, even before all this stuff came along and the internet came along, people have always chosen engineers gravitate towards, well, what is the easiest, quickest solution to solve my problem?
No, that's true. The difference is the availability of the other stuff, right? Whereas 20 years ago, you'd have, you wouldn't be using, a 68,000 series, Motorola controller to blink, to blink an LED, right? You just wouldn't do that because it'd be $30 for the chip itself, and then another $1,000 for the IDE or the circuit emulator.
Yeah, that's right. And the board and the development board would be $500 a pop, and you wouldn't have them just lying around.
Right now, it's the Launchpad. It's $4.30 when they were doing that promo. It's
that's right. Yeah,
it's easy.
Totally different. Yeah.
So it's
game's changed.
It's a fun world we're living in. I like it. I like this a lot.
Well. What you probably don't like, which we should talk about because this affects, this is serious business, right? Your government is shut down.
Oh, are we going to go into this? Yeah, I mean, I guess it's relevant.
Have to, right?
It's relevant, yeah.
It's relevant, right? Because
a lot of engineering dollars here.
A lot of engineering, right? If you want to get your FCC testing done, can't do it.
Yeah.
Right?
Well,
because the FCC
filing,
is shut down. Well, the final filing, right? FCC shut down.
Yeah.
Right? NASA shut down.
Yeah, that's a big one too. Yep.
Right? Every nerd's fantasy website, NASA, shut down.
Yeah.
They can't even keep the things going. Like, I don't understand why they don't even keep the website going.
I think it's
crazy.
It's not a money thing. I think it's just a maintenance thing.
It's a regular.
Right? Yeah, and it's also showing that they're shut down. I'm sure that there's a reason for that
they're sending a message. Yes, they're sending a message.
I would. I'd be pissed. If I was NASA, I'd be like,
of course.
Dude, we're in space right now. You can't figure out I don't even want to get. I get very upset about this.
We've got rovers on freaking Mars. Do you want us to just abandon them?
I know. Well, yeah, and that guy's.
What is wrong with your country, dude?
Please.
Does any other country is their government shut down? I mean, seriously.
Other countries dissolve their government, which would be, a nice thing around here.
Get a hostile take, overthrow the government or something.
Right.
I don't know. This is ridiculous. So, is this like affecting you on a daily? Is this affecting you in any way? No.
No, I was listening to a thing today. It's like 15 or 20%, and there's a poll said it was directly affecting them. It's like I don't know about polling stuff, but I think from there was a couple articles about it though. It does have a big effect on science and technology. I think Phil Plait, the bad astronomer guy, posted it.
Right.
But it does. It think about like research grants, like tons and tons of research grants come from government funding, like NIST and NIH type stuff. A lot of drug trials, that kind of thing. And it does. You're right. It does affect, and it's not just the states either. Like if I get funding from that kind of thing, and then I need to buy a piece of test gear from Australia, as if you guys could make it. But that would affect.
We choose not to.
Right, of course. It's not hip enough, right? But it does affect that from the global.
Or if China shuts down because of their public holiday, you're screwed. We talked about that before. Yeah,
exactly. There is no doubt that this will have ripples in the global economy from an electronics perspective. I'm not sure from a like a chip supply kind of thing. I don't know if that actually drives anything, but it definitely has people nervous, so I don't know. I hope it goes away soon. I will say they're all dumbasses. Is that sufficient?
That is sufficient. Thank you.
Okay.
Yep. Yeah.
But yeah,
I would have preferred it said with a bit more aggro. But,
right. Well, of course. Right.
Yeah.
Yeah.
I'll
so
take anything I can get.
Yeah.
That's about as aggro as you get.
Right. Of course. Right.
Yeah.
What else? We're kind of running down here. Did you see this new LT part? I love this thing. I guess we could call it
Chip of the week, is it?
Yeah, I think so. But it's $40. So you want to talk about expensive?
$40. Oh, is this the 5-volt one? Is this the 5-volt 18-bit ADC?
Plus minus 12-volt input ADC.
Right. Okay.
Yeah, it's beautiful. Yep. It's like mega sample, 18-bit, plus minus 12 volt. But it's the same kind of thing as like, so there's pictures that John was taking, right? That was like a module and that kind of thing. A lot of the companies aren't doing this. They're I'm not sure if this one's actually a module or if it's, I think it is a module because of the size of the resistors that they put internally. But they're just doing a voltage divider internally with like laser trim resistors.
Right, yeah, of course.
But this is a growing trend where you have, laser trimmed resistors that are better than the ones you're going to want to buy and put outside. Then you don't have to worry about the parasitics of like packaging, right? So if you have an ADC that has, if you have discrete ADCs or discrete packages rather for your ADC, and then your buffer amp that drives the ADC, and then all the front end circuitry and instrumentation amps and all the other stuff, it's like, there's all the inductance of the each pin on each package, right? And then you have the tolerances, which could all, when they all stack up, if the one resistor outside the package drifts the opposite direction of the other resistor, it's like, you have to account for that
screwed, and then you got input capacitance, you got all sorts of stuff to take
exactly right
into account.
And so this kind of system design, it's from as I always say, from an analog perspective, it gets more boring, right? Because I don't have to do as much. But on the other hand, it's like, in terms of the actual specs you can get out of it, right? You could design in an 18-bit ADC, but if your front end is crap, then it doesn't matter. Mm-hmm. And so, these kind of parts are really cool. And I like these parts because this is kind of like, quote unquote, above the rails, where it's like a 5-volt input and it can do plus minus 12, although they're cheating with resistors. But then Maxim has a bunch of above the rails parts where they actually use like a charge pump internal. And
above the rail is trademark, I believe.
Oh, really?
Ooh. Oh, yeah. I think somebody's trademarked that. It could be Maxim.
Okay.
Or is it beyond the rails? Somebody's trademarked above or beyond the rails or something like that.
Yeah, right.
Wankers.
I know, right? But those parts are really cool.
Hang on. Linear, I'm on the website here. Linear have trademarked the term quick eval.
Really?
Yeah, like a quick evaluation. With no C, it's QUIK, because they probably couldn't trademark QUICK.
Yeah, that's the next step when you can't get the patents, or you don't want to give away all your secrets. Yeah, there you go. That sounded solid, man.
That was.
You're looking at the datasheet or what?
Yeah, I'm looking. No, just the blurb website, the press release, whatever it is. Wank,
Yeah.
And $30 in 1,000-piece quantity. Woohoo! That's what we're talking about right at the start of the show with the testing and everything else. They're going to fully characterize and test this part.
Right. Exactly.
It takes a lot of time, and that translates into money.
Right, exactly.
So
and as all of these companies are moving towards modules, and I can't even tell if this is a module or not.
It's in an
MSOP
SOP. Yeah, it's in a 16-lead MSOP, but who knows what's actually physically in there.
Yeah, that's... I'd like to see a video. I haven't seen any videos of that yet, where they actually, like... I'd like to see it, like, pouring the polyamide, like with the actual...
Onto the lead frame,
Yeah,
they stick the die onto the lead frame, and then they do the bonding, and then they injection mold the...
I imagine, like, like, when you're, like, driving by the construction site, and there's, like, big, gruff guys, like, pouring cement. I imagine that, like, but on, like, a super micro scale. Hey, Lenny, you're getting this crap everywhere!
Right, and he's got his bum crack hanging out, and, and he's...
Tiny little cement truck with just pouring polyamide,
All right, and he's got a checkered shirt with his sleeves rolled up, and
in the back of a Fabs somewhere.
Thongs, That's Australian thongs.
Flip flops, right? Yeah, of course.
Yeah,
right.
Yeah, right.
Yeah. Yeah, I think this actually is I think it is a module just from the
That'd make a great spoof video. Someone like Linear or something like that should do a video like that.
Yeah.
And actually, have a big construction guy with a bum crack hanging out and like actually pouring something, making the chips and
Yeah.
it'd be hilarious. Sorry, sidetracked.
That's okay, man. Maybe they'll hire you to start doing that.
Right.
Oh yeah, you're right. Beyond the Rails is trademarked by Maxim. But it's got the dashes between the words Beyond the Rails.
Oh, right. Well, that's important. Yeah.
Yeah, right. Of course.
Yeah.
Yep.
Wankers.
Yep. Yeah, you gotta have something for the lawyers to fight over. No, I wanted to call it Beyond the Rails. Yep.
Dear Eddie.
What else we got on the list? There were some other ones that I wanted to talk about real quick. What was it? Nope. I can't find it now.
You're telling the story.
Yeah.
There's a new Internet of Things podcast.
That's what it was. Yeah. That's not going to be I don't think it's going to be super technical. It'll be more like on the gadgety side, as these devices actually go into the home, like those Wemo switches and all those kind of things, which are interesting. I mean, like there's a lot of interest in that kind of thing, but I think eventually that becomes that's like the divergence of like when, homebrew computing went into like full scale production type stuff, right? Like that's like the full scale production. It
suddenly
type of
goes
things.
Outside of our world.
Right.
That's not our world anymore. Yep.
Right. You get people that are interested in integrating this kind of thing in in an application environment type of thing where it's a packaged product. The most you're going to do is, download new firmware to it, right? That kind of thing. Yep. Hardware is out of the picture at that point. So, but it's still interesting. It's a space that we talk about on here a lot. And that is going to be, as people migrate from, the gadgety Kickstarter type of Internet of Things to like the full-blown, gone through Dragon Innovation or someone else, and now they're selling millions of units type of thing, seeing that transition will be interesting because it'll get more exposure to the general public, and it'll become part of the, other, you'll start seeing ecosystems pop up around it too, and then that will eventually push its way back down into what people develop for, right? So if you're building new hardware and there's some Wemo ecosystem or like ifttt.com, if this then that.com, right? People are developing to try and talk to that kind of thing because it's this, basically it's the least common denominator of where everybody wants to go to hook their things up. You're going to design to that spec then, or
got it,
Wi-Fi, whatever.
Speaking, we can now use more electronics gadgets on planes.
Oh yeah, that was fun too.
The FAA of what stuff have they changed exactly?
Last I had read about it,
we can take our Arduino on the plane and hack it, and and
I think this is more like you can use your phone, and make. I don't think you can make calls, but you can use it like you can be listening to music and use your e-reader and stuff like that.
I thought you've always been able to do that.
Not in the U.S. at least.
Okay. Well, you have here. You have to turn them off, but as soon as the seatbelt light goes off and you've reached altitude, you're allowed to.
Right, and it's interesting.
Does that mean that you're allowed to use them during takeoff and landing, or is it?
Exactly. Yep.
Ah, right. Okay.
Right. So the old regulation was actually it was the seatbelt sign because it was above 10,000 feet, and the interesting thing with that was because of back in the 70s, it was actually terrestrial radios that was the last time they actually found interference with pilot instrumentation. Right. And it just carried through this entire time, which is crazy.
Yep.
I mean, that's just showing how slow regulations move, right? So now they're finally rectifying all that stuff and changing the regulations. Because you think about like an analog cell phone back in the day, like not even the 70s, that was 80s, right? Those things were outputting watts. I mean, like you could actually get, you could get burned from that kind of stuff, right? It's like, and now it's like, with all this.
Well, it's watts, but it's peak. It's
right. Yeah, exactly. Average is milliwatts, right? I mean, those things turn on for fractions of seconds and turn back off.
But it's hard to get once you've put rules in place.
Yeah.
Government departments and other regulatory agencies just do not want to change them because no one wants to hang their balls up on the chopping block, right? and right,
because if a plane crashes, then they're screwed. Yeah.
Yeah. Or, it's the same thing with the, you're not allowed to use your mobile phone at the petrol pump. Urban myths like that. And it's just, it's crazy.
I didn't know that one.
Or speed limits, for example, car speed limits, right? Road speed limits. Once they've set the limit to, 60 kilometres an hour, nobody wants to increase it, right?
They do in Ohio.
Because as soon as they're a single... single
Ohio.
death, because you're responsible because for that death because you raised the speed limits, and it's just
They've been up and around here, and I love it. Went from 60 to 70 miles per hour. Yep.
Yeah, awesome. What is that? Just on regular roads, or is that like rural?
That's
sort of
no,
main
that's
roads?
like interstate type stuff.
Oh, right.
Actually, a lot of the old stuff I think was based on the 70s of like emissions type stuff because of cars were peak efficiency at 55 miles per hour type of thing. I thought that's true. That could be wrong. I'm talking about there.
Right. But yeah, I just find that's change like this is always a big deal because it's bloody hard.
Yeah, and
it
there's
rarely
a lot
happens.
of distribution as well, right? I mean, like, I don't know. I guess that's it. I don't know. What else we got? Anything else? SparkFun put all their stuff on the Upverter catalog. That was interesting.
Yeah, heard about that.
Yeah.
Haven't actually checked it out, but...
Yep.
Well, I don't think you've checked
Everything's
out
up there,
Upverter yet, have you? You should do that, Dave.
I had a play with it, but
Yeah, okay.
nah. Yep.
Yeah, we should, maybe we should set up like a race. Like have like a people who are best at certain... because that's the only way you can really compare stuff. You have the same design, and you have someone who says, I am the best at KiCad, or I am the best at Altium, or I am the best at whatever. And then, because if you just throw them in a new CAD package, you're always going to be clicking around for whatever. So it has to just be a race on your favorite, whatever CAD package you like anyways.
Yep.
So maybe we can have maybe you should do that at the Maker Faire. You could be like the
but
announcer,
when you're using
right?
different that's not fair, It's not fair because some packages you choose to use it because it's better at higher end tasks, but it's not as efficient at something like simple like Upverter. If you want to throw down a LED flasher, you're going to do it quicker in Upverter. I almost guarantee it.
Yeah.
It's just one of those.
That's
things.
true. And I guess any kind of the smaller tasks as well. It's often any task really. It's going to depend on how much of it you have to create from scratch, right? If you're building new libraries, you're going to be screwed no matter what.
And is the tool optimized for that sort of thing?
Right.
Yeah. I mean,
yeah, there are
flip it around and go,
solutions.
let's lay out an 8-layer board with controlled impedance traces, and let's try and do that in Upverter compared to Altium.
Right?
I mean,
Yeah, that's true.
It's just going to be no contest, right?
Yeah, that's true. Yeah, and I think that's what it ultimately comes down to is a lot of these packages start to delineate themselves at different price points and different tasks, like you said. I mean,
yep.
And interestingly, that Intel Arduino Galileo board, that's a 6-layer board. So I think that's the
right.
I think that's the first one.
That's probably
like that.
minimum. You have to do that to round out
BGA,
the BGA. I assume it's a BGA package, right?
It is BGA.
Exactly.
Yeah.
Yeah.
But that's interesting from the standpoint of if you want to replicate that design, it's a little bit less easy than it might be otherwise.
If you want to do it because basically the cheap ass boards stop at 4 layers. If you want 6 layers, it's suddenly
Yep.
you suddenly get shell shocked at the price of what PCBs actually cost to get protoed.
Oh yeah.
Or what they used to back in the old days.
Yeah.
Take it for granted that PCBs are cheap these days, but hey, they aren't if you still want 6 or 8
Or 12
layers.
24.
24 like was in that ATE in the board on the video I just did.
Yeah. It's insane. I love it.
I think the highest I've done is 18.
Yeah? Oh, that's intense.
I'm not quite sure I've done a 20. I can't remember precisely, but we embedded some coils in the...
Oh, nice.
There was one which is so simple, right? You actually look at the board and you go, like, why is, it's got like a handful of parts on it, just a little power supply, and you go, well, why is that a 24-layer board? It's because we actually put, it had to be low profile, so we put the wind-ins inside the layers and then put the bobbin, over through a hole in the board, and it made it incredibly low profile. Too. Yeah, it's great. But it costs you a bloody shitload.
Mm-hmm. Yep.
So yep.
Yeah.
Just a power supply board, and you've got to get it.
But those kind of boards can do like super crazy densities as well. They can do like hundreds of watts in small spaces.
It's great.
A couple square centimeters or something.
Because there's so much copper in there, it's basically a huge heatsink.
Yeah.
It's fantastic. Good fun.
Yep. I think, should we call it here?
Those were the days.
Should we?
Oh, yeah, all right. I will not be here next week.
Right.
So you will not get to hear my dulcet tones.
But we will be. It'll be me and Adam and Matthew from. Oh crud! I forgot the name of their company.
From the internet.
No, oh come on! I can remember that. Wayne and Lane. Jesus. Oh man.
There you go.
Yeah, Wayne and Lane. So they do a couple like Arduino Game Shield and a bunch of other fun kit type stuff. And Adam, I'm not sure if Matthew does as well, but Adam maintains a bunch of the KiCad repos and does the KiCad nightly or weekly or nightly builds or something like that. So we'll be able to talk about that stuff as well. So if you got any questions, we'll put up a post on the site so you can get them in for Wayne and Lane, the company, and Adam and Matt, the people. I'll be asking them about the name too. I know I've seen it once, but I was very confused. Yeah.
Oh boy.
Yeah. Other than that, I'd say buy T-shirts. What do you think?
Buy T-shirts. Do it.
Buy T-shirts
because we need money.
Yeah.
And they're cool. Because we don't have any advertisers at the moment.
No, that's all right.
So we're getting paid squat for doing this.
That's okay. We're paid in friendship.
Right.
Happy listeners.
Paid in good vibes.
That's right.
Awesome. It's good enough for me.
All right, man. See you in 2 weeks. Talk to everyone else before then.
Bye.
I know you're out there.
Listening to the Amp Hour.
I know that you're afraid. You're afraid of us. You're afraid of
the show being over this week.
I don't know the future. I didn't come here to tell you how this is going to end. I came here to tell you how it's going to begin. I'm going to hang up this phone, and then I'm going to...
Hope you give us iTunes reviews.
I'm going to show them a world.
How awesome iTunes reviews are.
A world without rules and controls, without borders or boundaries. A world where
everyone listens to the Amp Hour.
Where we go from there is a choice I leave to you.